Today we're going to be looking at object-oriented programming. Specifically, we're looking at a quick review of how it's put together and the ideas behind it. And this is for our CS 1400 course as a review before we take our semester final. We have a quick overview of what we're going to be hitting. Specifically, we're looking at the following components of this in class. We're going to be looking at objects, the packages that go along with them, what data members are structured, how they look, etc. We're going to talk about constructors as well as looking at methods and a quick introduction again to UML. First thing we want to look at though is the idea of objects. Objects are the foundational component of object-oriented programming. The idea again is that objects are things that can do stuff that have some properties attached to them. Hence the fact that it's the first word in object-oriented programming should be a big clue. These are the things we make in code. Again, the idea with this is an object is a thing. The idea behind it is that we are modeling the real world. We're actually trying to reflect what exists or what could exist so we can actually make a better and easier understanding of what we're doing inside our projects. Specifically in Java, we see that everything that we make, everything that we create ourselves, and all the large structures that exist in Java are all objects. Again, the reference for that would be the keyword extends. Everything that you create or every other object you use in Java extends object, because everything in Java is an object. There are a couple analogies we're looking at specifically when we're trying to understand the idea of object-oriented programming. The first one is the idea that a class, or what you write in Java, is the blueprint for an object that you're going to create. So the code that you write, the constructors, the data members, the methods, those are all the blueprints you make, that you're writing or designing to actually create and instantiate an individual object. The other analogy is the one that we can use to look back from all of our education, thinking back to the early elementary school where we're talking about the ideas of the parts of speech, and then looking at specifically a noun. Because an object is a noun, it is a thing. It is a concrete symbol or idea of something we're trying to create, and as such, when you're looking at a problem statement or trying to solve something, if you identify the nouns that you see within the problem or the things that exist in the problem, those will be the objects that either you create or use when writing the solution to it using code. We're going to take a look at the class structure next. So here's the class structure of a Java class, just a quick little put together for that. The first thing we'll always have is the package. That specifies where the code is found, what it belongs to, who is using it. We then have our header for our class. As you can see right here, we have a public class called Marshmallow Monster. We then have our declaration section. This is not required to be at the top of the file, but for class purposes, we've been keeping it there all year long, so it's easy to find, and we can identify immediately what data members belong to the entire class, rather than simply them variables that are used only in a single method. Next, we have all of our constructors. In this case, there are two. One with only two parameters, and the second with a parameter for every data member that exists inside the project. And then after their data members, we have methods that belong to the object. In this case, we have some of our getters and setters, because it's the quick and most basic methods that exist with almost every single object we would use. To start off with Java specifically, we're looking at the idea of a package. The packages are the places that we put our code. Specifically, it is the logical structure for all of our objects, where they go in existence to things. We've been using in class the idea of an MVC structure, a model view controller, and so we immediately separate where our code goes into those three categories. Those three categories make up our default packages for our projects in class. In the computer, the packages are simply just a folder, a way of holding together files in a way that makes sense. Again, the idea of having organized code is a lot better than simply having a big of code that we have to search through as a giant pile. You've seen your bedrooms when you don't clean them. We want to avoid having our code look that same way. If we look at Eclipse, these exist as a folder inside the project, usually over on that left-hand side in our package or project explorer. And again, it's also a folder inside our operating system like we just said. Here we can see the example from our package structure in Eclipse. We have our project name right there as Morning Monsters. And then we have our source folder where everything is contained by default in a Java project. Inside our source folder, we have the different folders for each of our projects. We have monsters.controller with our controller components of the app controller and the runner. In our monsters.model folder, we have the marshmallowmonster.java file, and in our monsters.view folder, we'd have all our GUI components, which I'm not showing at this time. And then as you can also see our system library that we're using simply because we're writing some code. Now, we also see the idea of a dot in there between monsters.controller. That dot indicates that controller is a subfolder of monsters. So that folder itself has the dots that we use inside our package name indicate that the after each dot is a new folder. So monsters.controller is a controller folder inside the monsters folder. Monsters.model is there's a model folder also inside the monsters folder, and there's also finally a view folder inside that monsters folder as well. So we have the dot operator to show that we're going to go inside it to get to the next level of the package, like we'll see later on in Java, and that we can see that organization, how those components fit, within that MVC structure for our code as well. The next thing we want to look at are our data members. Our data members are what we fit inside our declaration section. These are the properties or the values that are attached to our object. They make up our object. If we're looking for a relationship, it would be the has a relationship that we would see for our object members. So a car has a steering wheel. A monkey has a tail. Those are the components that belong to the other object. Data members can be either primitives or other objects. In the case of a car object, an engine is a completely separate object that is part of a car. And so you can have that, but you can also have, say for example, a number of doors, which is a variable on a car, which could be anywhere from 2 to 5, 6, 7, 8, 9, 10. I haven't seen a 10-doored car, but they could exist. We also want inside Java, specifically our data members should be specified as private, because we want to support the idea of encapsulation and information hiding, so the ideas of the data members cannot be affected externally when they shouldn't be. And so we use the visibility modifier of private for all of our data members when we declare them in our declaration section. If we look at that same parts of speech analogy, we look for the idea of an object. Our data members work as an adverb or an adjective because they describe or modify our object itself. And again, as I said, our data members are all placed inside the declaration section up at the top of our code. Here we see an example of the declaration section. Again, it's up at the top of the class after the class header, and remove my documentation I would normally place inside my file just so we could actually see this a little bit better. You see that in the comments right there. And I try and group my documentation, or my declaration section, by type. There are different ways you can write your declaration section. You can put together multiple declarations on the same line. But for purposes of identifying this, I put them all as a single line just so we can make sure we have all of them identified for our object like we did at the beginning of the year. And so we see the visibility modifier of private in front of every single data member in our declaration section. We then identify the data member type as a string, double, int, or boolean. And finally, each of the data members are specified by name and of course followed by our good friend, the semicolon. We next have our constructor section. Our constructors are the things we use to actually build the objects. Our constructors have a couple rules. They will always have the same name as both the class and the file. And we can have as many constructors as we wish. We could even have private constructors. And there are a couple good times to have a private constructor so we can make sure that the user doesn't create things inappropriately. We have a default constructor with no parameters that is automatically assumed to exist by Java unless we write one of our own. And we have the ability that we can use them to create or build our objects. Because that's the case, constructors have a job to initialize values for every data member inside the object itself. And so when they build the object, when you call the constructor, you should provide a value for every data member that exists inside that object in its declaration section. Java will allow you to write a constructor that does not provide a value for every data member. However, if you forget to assign data members to every value or object inside that constructor, you will then receive lots of null pointers, which, as we all know, leads to null pointer exceptions and apps that crash and burn. Something we wish to avoid most of the time. Our visibility can be specified, like I said, based on their use. 98% of the time, the constructors we write will be public constructors. There are some private constructors that exist, and we'll talk about them as we go along. But the biggest thing with constructors is the idea that we can have multiple constructors. We can overload them. As long as we have a different signature for that constructor, we can have as many constructors as we need. We saw in Marshmallow Monsters on that first screen that we had a 2-parameter constructor and a 7-parameter constructor. We could have different 7-parameter constructors or even different 2-parameter constructors, provided those constructors have different sequences of data members as parameters. And that's the method header or its method signature, or in this case, the constructor header or constructor signature. Now, one quick reminder on the constructor. A constructor looks like a method, smells like a method, but it's not a method. It never has a return type. It is simply the visibility modifier and then the constructor name. And so remember that when you are creating it, to never put void inside that constructor call, otherwise your app is not going to work properly and you'll get null pointer exceptions again, crashing and burning all over the place. Here we see an example of those constructors. We have our first constructor with 2 parameters, and inside that constructor we use this dot to refer to our objects data member versus the parameter of the method or the constructor that has the same data member name. So this dot name equals name. You can see right here that the blue of this dot name is different from the green of name, both in the constructor's parameter list and on the right hand side of the equal sign. So you're taking the one from the parameter list and putting it into the object itself, along with this dot number of legs equals number of legs. As we look at the bigger constructor, we see we have 7 different parameters right there, and each of those parameters is then assigned into the object using the same this dot structure. This dot x equals y, repeated over and over for each of those different parameters. The this dot is referring to the current object, and we use that idea so we can keep talking to our object versus simply referring to the variable itself. This allows us to keep variable names named, or variables named something that makes sense to us, and not having to have a special variable just because we're putting it inside a parameter. So we can avoid that confusion by using this dot to talk about the objects and the simple variable name when talking about the parameter. And again, like we see right here, notice there is no type between the visibility modifier and the name of the constructor. If we put a void there, instead of creating an object, it will simply call that method, which would mean it's not going to happen when we use the new keyword, and would cause null pointer exceptions all over the place. Our next section we're looking at when dealing with objects is the idea of our methods. Methods are the actions for that code. And this is a coherent chunk of code that exists inside a set of squiggles, aka the curly brace. A method should do one thing well, aka it should have a single coherent purpose. We can use one method to contain many other methods or that call other methods in the appropriate sequence. So we can have one action that calls many other actions to perform a bigger or more broad purpose. But we'd still have each method having one major action it does. That may take many lines of code. It may take only a couple lines of code. The size of the method itself is not the point, but rather how well it does the job it is assigned to do. The method itself should have its name reflected in its what we call it. So if, say, for example, we could name a method x, y, z, or q, followed simply by parens and whatever parameters it needs. However, calling .x or .y or .q will generally cause mass amounts of frustration and consternation on the part of the developer, you. So why make it harder for yourself? Give yourself a good variable name, give yourself a good method name so you understand when you call a method on an object what it is supposed to do. We can have methods that will either just act, aka a void type method, or methods that can return any one value, aka a typed method or a return type method. And we'll see both of those right here in just a moment. First, we want to look at the void method. The void method is identified by the void keyword. Generally, if these are seen externally, they're public. We then have the method name and any parameters that they would need. In this case, we were looking at the setters. The setters don't give you anything back when you call them. They simply just perform that action, changing the data member itself with the supplied parameter. As you can see right here, we have a set name passing it a string variable called name. And we call this .name, so it assigns to the object the parameter name itself and assigns it in there. There is no return keyword in a setter. There is no return keyword in a void method. Void methods can have a return statement listed, but it would simply be return semicolon. where it simply exits the method. That is only generally used in poor design or in cases of avoiding specific errors. Say, for example, you have access to code inappropriately, like say, for example, you're trying to retrieve a file from a network, and you don't want your code to crash when it has no longer access to that file, and so you simply force it to return, dumping you out of that method rather than continuing to cause exceptions. But we'll avoid that and talk about it another time. We have also return type methods. As you can see right here, our getters are always going to be return type methods. They're also generally going to be public if you're going to be a getter. And we can see that we have public string get name, and it has as a simple basic feature here the keyword return and then whatever type is being returned. In this case, the variable name is of type string. We have the same thing with a double variable, which is a primitive variable, and we have public double get number of legs where it returns number of legs. It is always best on a return to return a variable that has a value stored inside it, rather than simply returning just some random number or value that is stored for that. By using a variable, you can have it so you can make it changes to it as needed and also track it when you're doing debugging. Nice little reminder there for future lessons. Our final section we'll be looking at is the idea of UML, or Universal Modeling Language. This is a great way of visualizing code when we're designing it or doing a review towards the end of our project. The UML structure is a way of showing the relationship between classes in a visual fashion. We use this by drawing boxes with lines around them. And the different lines show the different types of relationships. Crazy concept, I know. In a UML class diagram, there are 3 chunks in a box. The top chunk is for the package and class, so we can see what its name is and where it fits. The second section is its composition. What are the parts of that object, aka the data members? And we specify the data members if they're visible with a positive sign, if they're private with a minus sign. And finally, we have our constructors and methods in the bottom section, and we use lines with arrows to identify those connections. Let's take a look at that over here for our monster class right here. And as you can see, we have the marshmallow monster object is inside the model package, monsters.model, specifying the package, : and then what object we're looking at. In our middle section, we have all of our data members. Again, keeping with our practice of keeping our data members private, all of them have a dash or a minus sign to suggest the visibility modifier on them is private. In our bottom section, we would right now only have public methods because it's a simple model object, and so it has no calculation or internal helper methods that would be specified with a minus sign. But all of our methods right here are public, therefore specified with a plus sign. And because we realize that getters and setters are done in mass, we can simply just write getters/setters rather than writing out every individual getter and setter. Save ourselves just a smidge of time. However, for our constructors, I find it very helpful to actually write out our constructors because we want to identify when we're sharing this publicly that we have different versions of the constructor to call and what we do. Notice how I'm, however, not specifying the data member names inside the constructors. I'm simply specifying the type. Again, this is designed to quickly show how your class is put together with its different methods, data members, and where it belongs.